Hey guys, welcome to another video where I'll be teaching math. I'm Abhinav. I've done both my bachelor's and master's in electrical engineering from IIT Kharagpur. In this video, we are going to discuss regular polygons, especially the regular polygon with 7 sides, and it is denoted by A, B, C, D, E, F, G. The side length of the regular polygon is given and it is 1 unit, and all you have to do is you have to figure out the value of this particular quantity. 1 upon AC plus 1 upon AD. AC is the diagonal of the regular polygon. AD is also the diagonal of the regular polygon, but a longer diagonal. So all you have to do is you have to figure out the sum of the reciprocals of these two diagonals. So this might be an integer question in your JEE mains or maybe your JEE Advanced, because the answer to this particular quantity will be an integer. It has got a very good concept involved in it, so make sure you stick around till the end. So what we are going to do in this video is to solve this problem using two approaches. The first one is the usual trigonometry approach, which is quite calculative and a little bit cumbersome. And in the second approach, we use something called as Ptolemy's theorem to solve this particular question. Alright, so let us go ahead with the trigonometry approach. So there is a very important thing that each one of us should know about the regular polygons. Every regular polygon can be inscribed in a circle. So these vertices of the regular polygon, they all lie on the same circle. Alright, so this is one fact about regular polygons that all of us should know. So let us assume the radius of the circle is r. So let us assume there is a center O, and let's join OE and OF. So OE will be R, OF will also be R, and FE is 1 because the side length is 1. It is given in the question. So the total central angle will be 2 pi. Since there are 7 sides, this angle will be 2 pi upon 7. Since this side and this side are equal, these two angles will be equal, and each one of them will be 5 pi by 14. Alright, so if you apply sine law in the triangle OFE, it will give you FE, which is 1 divided by sine 2 pi by 7, is equal to FO, which is R divided by sine of 5 pi by 14. So now you know R. R is equals to sine 5 pi by 14 divided by sine 2 pi by 7. So this is R. So now let us find out what angle alpha is. Alpha is simply the internal angle of the polygon. So that will be given by the formula n minus 2 into pi by n. So that is simply 5 pi by 7. So alpha is 5 pi by 7. Since AB is 1 and BC is also 1, these two angles will be equal, and each one of them will be pi by 7. Alright. So this total angle DCB is equal to beta plus pi by 7. But DCB is the internal angle of the polygon, regular polygon. So the value will be 5 pi by 7 is equals to beta plus pi by 7. So therefore beta is equal to 4 pi by 7. Now we have alpha and beta. So what we have to do is we have to find out an expression for AC and an expression for AD, since that is asked in the question. So if you apply sine rule in triangle ABC, you get, so this is alpha, you get AC upon sine alpha is equal to 2 times the circumradius. What is the circumradius? The circumradius will be simply R, because this green circle passes through A, B and C. So it is simply 2R. So this gives you AC is equal to 2 into 2R sine alpha. Alpha is 5 pi by 7. We have already derived. So this is alpha. Now let us apply the sine rule in triangle ACD. In triangle ACD. So that will give you AD divided by sine beta is equal to 2r. 2r will be, circumradius will be r, because this green circle passes through these 3 points. Alright. So AD divided by sine beta is equal to 2r. So this implies AD is equal to 2r sine beta is 4 pi by 7. This is also derived. Now you have to find out 1 by AC plus 1 by AD. That will be 1 by 2r multiplied by 1 by sine 5 pi by 7 plus 1 by sine 4 pi by 7. You also know what r is. R is sine 5 pi by 14 by sine 2 pi by 7. So r is 1 by 2 sine 5 pi by 14 multiplied by sine 2 pi by 7. Now sine 5 pi by 7 can be written as sine pi minus 2 pi by 7. So that will give you sine 2 pi by 7 here. So this is sine 2 pi by 7. Alright. Similarly, sine 4 pi by 7 can be written as sine pi minus 3 pi by 7. That will give you sine 3 pi by 7. Now if you take the LCM and add them up, you get sine 2 pi by 7 by 2 sine 5 pi by 14 multiplied by sine 2 pi by 7 plus sine 3 pi by 7 divided by sine 2 pi by 7 multiplied by sine 3 pi by 7. So this and this gets cancelled. So now in the numerator you can apply sin C plus sin D. This looks something like sin C plus sin D. Sin C plus sin D. That will be 2 sin C plus D by 2 cos C minus D by 2. So 2 sin C plus D by 2 will be 5 pi by 14. Cos C minus D by 2 will be cos pi by 14 divided by 2 sin 5 pi by 14 sin 3 pi by 7. 2 sin 5 pi by 14, 2 sin 5 pi by 14. These two will get cancelled. So now it is simply cos pi by 14 by sin 3 pi by 7. Sin 3 pi by 7 can be written as sin 6 pi by 14, and this can be written as sin pi by 2 minus pi by 14, and that is simply cos pi by 14. So sin 3 pi by 7 and cos pi by 14 are equal. So this and this are equal. So this quantity is equal to 1. So your 1 by AC plus 1 by AD is simply 1. So this is a very famous result and you have to remember this result. Alright. So this is how you solve this question using trigonometry. So now let us see how this question can be solved using Ptolemy's theorem. Alright. So that trigonometric solution is very cumbersome and time taking. It is calculative also, and it is very easy to make mistakes in that method. Now let us see what Ptolemy's theorem is and solve the question using Ptolemy's theorem. So Ptolemy's theorem is valid only for cyclic quadrilaterals. So PQRS is a cyclic quadrilateral, meaning which it can be inscribed in a circle. Alright. For a cyclic quadrilateral, the product of diagonals, so PR and QS are diagonals. Product of diagonals is equals to the sum of products of opposite sides. You do the product of these two sides, PQ times RS, and you do the product of these two opposite sides and add them up. This sum will be is equal to the product of diagonals. So this is Ptolemy's theorem. Alright, so now let us apply this Ptolemy's theorem and try to solve this question. So here you have a regular polygon and AC is one diagonal, AD is one diagonal. Alright, now let us join AE also. Alright, let us join AE, and so now A, C, D, E is a cyclic quadrilateral because all the vertices lie on a circle. Alright, ACDE is a cyclic quadrilateral. So let us apply Ptolemy's theorem to this particular quadrilateral ACDE. So this one. Alright, ACDE. So what do we get? Product of diagonals. Diagonal is AD multiplied by CE. This is equal to product of opposite sides, DE times AC. DE times DE multiplied by AC plus CD multiplied by AE. Alright. Now your CE will be equal to AC. So instead of CE, we will write AD multiplied by AC is equal to DE. DE is the side. The side length is given. It is 1 multiplied by AC plus CD. CD is again side length. It is given 1. AE. AE will be equal to AD. So this AE and AD will be equal. So AE can be replaced with AD. So now AC times AD is equal to AC plus AD. Divide the whole equation on both sides by AC multiplied by AD. This and this gets cancelled, this and this gets cancelled, this gets cancelled. So 1 is equal to 1 by AD plus 1 by AC. So here you just have to recognize that this is the quadrilateral to which you have to apply the Ptolemy's theorem. And once you write the formula, it is done. In one step, you'll get the answer. Maybe your trigonometry solution might take 5-6 minutes to solve correctly, but this solution will take only less than a minute if you are able to correctly identify the cyclic quadrilateral to which Ptolemy's theorem has to be applied. So the goal of this video is to put this thought in your mind. So you will not be knowing all these techniques when you encounter the problem for the first time, but now you know this trick, and whenever you see a similar kind of problem next time, try to apply this. And if you like the content, give it a thumbs up, share this video, subscribe for more such content. Also, you can try joining the Telegram channel in the description. See you in the next video.